Hello and welcome to the AWS Certified Cloud Practitioner training. This is the session 8. There'll be two more sessions, and then those 10 sessions will be enough for you to clear out the AWS Certified Cloud Practitioner. Um, I've designed this course in such a way that we are able to go through all this information within 10 sessions and go through sample questions as well and get you ready for your certified cloud practitioner exam. A little bit about myself. I'm Anand Thirumanur. I have over 3 years of AWS experience. I recently completed the cloud practitioner exam, uh, and given that I've been working with AWS and GCP for the last 3 years, so I have very good exposure to both the clouds, and I've worked with multiple clients. Where we have implemented different solutions using each of the cloud solutions. Let's go through the four basic domains that we are being covering. We've covered the cloud concepts, the security and compliance, the technology. This will be in the last session, and then in the next session we'll cover billing and pricing, and in the last session we'll do a lot more question and answers uh, and get us ready for the certified cloud practitioner exam. Within technology, today is going to be the last session. As always, if you can like the video, subscribe to it, we'll be really, really thankful. We did cover within the technology, we covered the storage services very extensively, compute services very extensively. Then we uh, took one session for database networking and analytics and machine learning services, because those are the services that are typically asked very frequently in this exam. Then I'm today going to go through migration services, application services, developer tools management services, and media and mobile services. This would cover most of the other options in most of the questions. So sometimes AWS asks a question, and they might give you four options, and you may not know the like one of the developer tools that they're quoting or one of the new services that they're quoting, but you may be able to figure out the answer by elimination or by knowing what each service does. So let's go through all these services. Let's look at what these services do at a very high level. Uh, for this exam, you don't have to go even more in depth unless you're doing the architect certification or the developer certification. You don't need to know much more about these services uh, to be able to complete this exam. So, quick overview of the developer tools. There's something called Cloud9, helping with cloud development. Code build is where you can build your code, so it gets compiled and then built. So, code build helps with that. Code commit is a source control service like Git, where you can manage your source code. Code deploy helps with automatic code deployments. Code pipeline is used along with code deploy in a lot of sense. It's a continuous delivery service where you're able to like do an automated test of regression test of all the code before you migrate and use code deploy. So the code pipeline builds the pipeline where you go and call a regression test, and then you call code deploy so that the code can get deployed. Um, CodeStar is a tool where you manage your software development activities in one place. So this is a management tool for all software development teams. The command line interface, you will use it a lot when you start getting into AWS. At first, people typically get into AWS by using the web interface. They go there and set up an EC2 instance, choose all the options, and then uh, get everything set up. But as you get used to that, it's going to take a long time to choose all the options and save and somebody setting up a dev region and they want to set up a similar QA region, if they go through all the options and they miss certain things, then that's going to cause concerns. So they would rather code everything using the command line, type up one command and bring up the EC2 instance, or set up the Lambda function with one command. They can use the command line interface to do that. If you're a developer, you'll be using the AWS tools and SDKs. That is a compiled. It has all the tools that you need if you're using a JavaScript based developer, because you're a full stack developer, or if you're using a Python developer, and you get the Python development environment with uh, ability to connect to EC2 instances, ability to connect to Lambda functions, ability to go into the CloudWatch and watch everything. So everything can be done using the SDK and the tools that AWS provides. X-ray is where when you have distributed applications and you want to analyze and debug, um, it gets confused with CloudWatch, but this is where you put in all your debug statements, and you're able to analyze all the distributed application logs that you put in. Managed artifact repository is code artifact. So here, if you want to have your code in a repository, and you want to share it with other people working in your organization, then you can put that in AWS code artifact. AWS Cloud Development Kit is a tool similar to SDK, but it's very specific to cloud development. Cloud Shell is something that you have a virtual computer that you can bring up whenever you have a AWS, and this is free to use. So you can bring it up, run the commands, and then connect to your interface, and then use it. So you can run all your commands in Cloud Shell. Machine learning related tools. The most important one is Amazon SageMaker, the one on the right. So Amazon SageMaker is where you have your own, you can build your own model. You can have a notebook such as Jupyter Notebook, and then you can build your model, train your model, and then deploy your model using Amazon SageMaker. So all that can be done for a recent retail client. We have built a machine learning model. Amazon SageMaker is what we used to build it, train it, deploy it. The next one from the right we look at is Amazon Recognition. Amazon Recognition is where you're working with image recognition or video recognition. You want to if you're building an app. So I haven't worked with this, but I was working with somebody who said that they had built a image sharing app, where whenever somebody uploads an image, they want to see if it has the person who's uploading it. If they identify it, they want to be able to tag that person, and then like notate that to other users that this person has uploaded something. So with Amazon recognition image, that was one solution where they were considering. So they could use Amazon recognition image or Amazon recognition video to identify the people. Sometimes there are rules in certain countries, or most countries, that if there's any offensive material that needs to get flagged and possibly reviewed by someone and then removed from the platform. So if there's a image sharing or a video sharing app, if you want to see if something is offensive, then you don't have to flag everything and get it manually reviewed. Amazon recognition video can do that for you. It can flag potentially harmful videos, and then you can either completely flag it and remove it, or you can flag it for some manual review and then remove it in case the manual review does not go through successfully. Amazon Poly converts text to speech, but it's machine language based lifelike speech, and it can also help with voice that with multiple voices that they have in Amazon Poly. Amazon Lex um, builds conversation bots quickly. This can be both voice and text apps. So if you want to build a chat application where people come into your website and you want Lex to be able to respond to them based on the questions that they have, inquiries that they do, Amazon Lex can be a solution for that, for building that conversation bot. And this can do voice with voice as well, not only text. So if you're building an app for Alexa, then you can use Amazon Lex. um, Amazon Deep Learning AMIs. Those are Amazon Machine Images. Those are customized for deep learning or machine learning. So those images can be built up and then you can use those. Amazon SageMaker Ground Truth is a data labeling service. So for instance, I was working for a restaurant chain company. So they had multiple restaurants. They wanted to like look at the images from the receipts that they have, and identify like the listings that are there in the receipt. For instance, if it said Merlot, they want it to be they want that to be labeled as a wine. So for that, you can use a data labeling service. So you can actually label every Merlot to be a wine, and you can say it's a red wine, and you can label those things. And after you label it, you can either use it for machine learning um, and like make it better, or you can like use the data labeling service in your analytics process. Let's move on to machine learning. To migration and transfer. So for transfer of data, the most important service was the database migration services, which we saw when we took care of the database related part of this. Other than that, we have a suite of migration and transfer. Not going to go into each of them and say what they do, but rather, if you remember these names, that application discovery service, server migration service, application migration service, transfer family, AWS data sync, migration evaluator, and migration hub. So these are the tools that AWS provides. And sometimes you might have a question that does not involve migration and transfer. If you see these options, then you can say, okay, these are actually migration services. So this probably is not the answer. So you can use those that information to eliminate or choose based on what you know. The application integration services. These are when application A wants to talk to an application B, or if you load a S3 some object into S3 bucket, you want that to trigger or send an email to somebody, or you want that to go ahead and call a Lambda function. So if those kind of things you want to integrate between different applications or different workflows, then you use these tools. The simple notification service is where you can call, you can send an email, you can call another function. Simple queue service is where you send a message when an event happens to another application, other Lambda function, or any other AWS service. Amazon MQ is similar to the message queue. So when applications want to talk to each other, they can uh, like message, put it in a message queue, and then it will be picked up depending on how we set it up, either first in first out, or based on last in first out. So it can get picked up in multiple ways, and then the other application can then pick that application up and then do it. And this can do it. The second application, which is getting the messages, can read it when it's ready to read it. It does not have to be always available for the first application to be sending the message over. So the MQ actually holds the message for it, and then the receiving application can read it when it wants. AWS App Sync. Step functions is important because any microservice orchestration that we want, serverless microservice orchestration we want, we can do using step functions. The event bridge is for event related applications. So event bus, if you know what that is, so that's what event bridge is. So any kind of event driven um, application that you build, you would rather use event bridge. The event can be either from the own application that something happens, and then that should trigger something that can need a use of Event Bridge, or it could be from another application or from an outside like trigger. Console mobile application, Express workflows, Amazon app flows is between apps, and Express workflows where if this happens, then next this should happen. That's a way of building your own workflow. Typically for batch processes, you want to process something and process a set of files, and then after those files are done, then it needs to get archived, and then after the archival happens, the uh, the files that were copied need to get loaded into Redshift. So if you wanted to build those kind of logic, you can do that using workflows. And AWS Express workflow is one way to do it. A slightly better way to do it, or at least the ways I have done it, is using Apache Airflow. Uh, Amazon has managed service called Amazon Managed Workflows for Apache Airflow, which is a service that already has Apache Airflow installed. You can just directly start using it. And one other important one, API gateway. So API gateway is where you define all your API like connections. So if you have an API which is a put, and then it updates your store information, then you build that with a version 1.1, 3.6, build in all the versions there, build in all your API related details, and then you can have that API gateway call a Lambda function so that API gets executed, or in any other way you want to do it. So the important pieces from this slide are simple notification service, SQS, API gateway, step functions, and event bridge. So familiarize yourselves with those names and what they do. The next set of things are AWS Amplify. This is a developer tool for front-end mobile and web developers, so they can quickly develop their web or mobile application. For web and mobile app testing, there's something called AWS Device Farm. AWS provides tools for testing it. For location services, it helps with like maps, like routes between places, geospatial information, all those things. Just like a Google Map API, Amazon Location Service provides something similar. And I'm not very aware of this service, so I cannot compare this with the Google Maps API. Let's dig into a little bit deeper into a few things, and then we'll go into a bit of questions that we can do. Amazon AppStream 2.0 is a fully managed non-persistent desktop application. So when you are working for an organization and they don't actually provide you a laptop, they could actually provide you an AppStream 2.0. So you will have everything that your organization provides remotely set up on remote desktop through AppStream. So you can log into your own laptop that you have at home, and then connect through AppStream 2.0, and you get into a persistent desktop. That means the desktop is not gonna keep changing whenever you log in today versus like a week later. You're going to get a persistent workflow. You have the same apps installed for you, and you use them securely and within the organization network. You are not worried about getting access to like URLs. Those can get blocked in the AppStream environment, and it is connected within the corporate network of the uh, the company using VPN. Yeah, so that's AppStream 2.0. This is another thing that you could probably get questions from. Ops workflow. This is a configuration management service. So if you don't know what a configuration management service is, if you want to automate your configurations for your servers, your you have multiple configurations for your Lambda functions. So you want to configure all that and store it as a code, like like a file that has all the configurations together. And then if you want to replicate the same configuration in another environment, you just copy the file, probably change a couple of things because it's a different environment, and then use that file to actually bring up the whole environment. So that is being done by OpsWorks. And typically, I've seen clients use Chef and Puppet. Those are the most industry-leading configuration management tools. And OpsWorks is a managed service which provides like Chef and Puppet. So you can use Chef or Puppet. In that way, you can automate the configuration for your servers and stuff like that. So all your EC2 instances, if you have like they have to be part of this subnet, they have to be like open to these IP addresses. Those are part of this VPC. So all those things, there are some security groups you attach to EC2 instance. So all those things can be configurations, and all those configurations can be automated by writing like one set of file, and then that has all the configurations, and then that you can use to deploy like into dev, into QA, into prod with slightly different levels of logging, different levels of RAM, memory, etc. But everything else you can just keep it similar, and then scale it up or down based on which region it is. That's another important one. AWS Marketplace. AWS likes to ask a lot of questions around Marketplace, but it's a simple service where you go in, search it up. The web interface looks like this. You can choose like operating systems, storage, network, security, and multiple other software that people share, the companies share. Those get in this catalog. You can just choose and then deploy it. For example, if you want to set up your own website using WordPress, so there are vendors who provide complete WordPress solution, including setting up a EC2 instance, setting up the networking for that, setting up a LAMP on it. That is, you have Apache server, you have Linux, you have MySQL and PHP, everything installed that WordPress needs, and WordPress installed on top of it. So all that can be packaged by somebody and then sold. It is packaged by somebody and sold on Marketplace. So you can go ahead, choose that provider that you like, choose the option that they have, and then you can set up and then install it. That would install the EC2 instance, set up all the networking needed for it, set up everything that is needed with respect to that. Next important tool that we want to see is Cloud Formation. Cloud Formation helps you provision, model, and manage third-party resources. So if you know what infrastructure as code is, so this is another tool. This is the AWS's response to infrastructure as code. When you write infrastructure as code, then you don't have to code your infrastructure. You don't have to go into the web interface or into the CLI and type in commands, or go into the web interface and choose all your options and then build it. With the infrastructure as code, you can template your code and put it in a file. Typically, it's a YAML file or a JSON file, and then using that, you can code your infrastructure needs. You can say within the YAML file, you can say that this is the EC2 instance that you need, or these are the multiple EC2 instances that you need, and these have to be connected to other, like within that, all three should be within a subnet. Those would be within this region, this availability zone. You can choose all that as infrastructure as code, and then you can set it up. And when you run the infrastructure as code, you can set up the whole region, including setting up for dev, QA. You can set it up differently, and you can use that. And if you want to build a new application, which is a copy of this application, so you can use that in infrastructure as code, and then copy it over, and then change into the new application name and new application details, and then recreate the whole infrastructure. This could include auto scaling, EC2 instances, any kind of connections between EC2 instances and databases. Everything can be included in your infrastructure as code. This is different from configuration as a code, which we saw where we use Chef or Puppet, because configuration just talks about what are the options to configure them, not the infrastructure itself. So, there is a difference. If you want to research a little bit further, and if you don't understand, you can go ahead and do that. Another question that gets asked a lot is like AWS likes S3 as an important question for AWS Certified Cloud Practitioner. One of the things that they ask is how do you transfer your data to S3? So when you do it offline, you've seen that picture that I showed of the snowball device, which is like a computer, which is like a box that they send to you, and then you can actually transfer your data into the snowball or the snowball edge, which is a smaller version of that device, and then transfer that. And then you can either connect it through direct sync and then send it over, or you can ship the whole device, send it to AWS, and AWS will transfer it into the cloud. A snowmobile is for like huge set of data where a truck pulls in and then you move your hard disks there and then the data gets moved over to AWS. All those options are offline. So you physically ship something and then that gets loaded with data and then moved over physically. Online is what is typically used by most of us and most people. What can you do? You can have a S3 command line interface. So if you install the S3 command line interface on your device that you're using within your corporate network, then you can use the S3 command line interface either on your server or from your like desktop that you're using, or laptop that you're using, and then use the command line interface, and then you can transfer data over. And you can do this like you have options including doing multi-part uploads for large files. You can do them as batches as well. AWS Direct Connect is an interface where you have a physical networking with AWS, where you connect directly from your router, your company's router, to AWS's router. So there's an actual physical LAN line going. Okay, data sync is where you can set up software on both the corporate network and on AWS, and you can have a network. You can quickly transfer data between your corporate data servers and the AWS network. AWS Storage Gateway and Partner Gateways. Storage Gateway is, like is is a gateway server that is provisioned at the on-prem location. So you provision a storage gateway, and then that helps with transferring data quickly between the VPN network uh, at the at your location, at your company, and AWS. And partner gateways are where you don't have access to AWS immediately, but you have AWS partners which are pretty close by. So you can use the partner gateway and transfer data over. S3 transfer acceleration is another service. Kinesis data, where you can stream data. You can build a glue data pipeline, or you can build a Airflow data pipeline. You can also use the database management system, which is another transfer thing which we saw when we were looking at database management system. So these are so many ways you can transfer data to your Amazon S3. Systems manager, this gives you visibility of all your infrastructure on AWS. You might have, your teams might have set up a lot of EC2 instances, a lot of networks, a lot of RDS instances, S3 buckets. You can look at everything together in the systems manager. You get free data transfer. So anything that you move into the S3 bucket, you don't have to pay for. Um, um, like if you transfer data from the internet, um, like not using a snowmobile, so you actually transfer it during internet into S3, you don't have to pay for it. If you transfer between one S3 bucket and another S3 bucket in the same region, you don't have to pay for it. If you transfer from one to another, you definitely have to pay for it. Other region, S3 bucket to another S3 bucket, but it's a different region, you definitely have to pay for it. If you transfer from a S3 bucket to another AWS service within the region. Say, for example, you move into Redshift, but you use the same region, then you don't have to pay for it. And typically, if you transfer data out of AWS, you'll have to pay for the network cost. But in case of data transfer to Cloudfront, to an edge location, if you remember what Cloudfront is, it's an edge location where you could help worldwide customers look at your images, videos, and cache. So Netflix uses Cloudfront or like a product from another company, actually, not Cloudfront, which is a competitor of Amazon CloudFront. They use that, but they have the similar edge capability, so that anybody who's streaming videos from Netflix from different geographies in the world can get the streaming done much quicker. Let's start looking at a few questions. So the next about 30 minutes, we look at questions. Which AWS cloud architecture design principle is enabled by availability zones? So we've looked at availability zones. That is, within regions there are availability zones which have a use where when one availability zone is down, a nearby availability zone within the same region would have completely different infrastructure. So they might have different power companies, networking companies, different ways in which disasters can be avoided between these two. So they build it that way. The reason for that, for having different availability zones, what that helps with is it helps with not losing any kind of information. So if you look at that, if you think about it in that way, the four options we have are disposable resources instead of fixed servers. This is a cloud principle where instead of having a fixed server using when we are on-prem, when you actually move to the cloud, you can actually dispose of the resources when not needed, and you can save money. So you can pay as you go. So that's a cloud principle. I don't think that has anything to do with availability zones. Removing single points of failure, probably because when you have multiple availability zones, and the way the availability zones are designed is that one availability zone uh, would typically not go down when another availability zone is going down as well. Say there is a flood or a wind, heavy winds, and power lines go down for one company. The other company might still have its infrastructure up, so you might have the two different availability zones. One of them at least working. So it does kind of remove single points of failure, but it's not an essential. That's the only reason for it. So I'm going to keep reading on, and if I can't find anything much more relevant, I'm going to choose that. Amazon EC2, yeah, definitely EC2 is set up within availability zone. When you choose EC2 instance, you do choose what region you have to put it into, what EC2, what availability region you put it into. But it's not a cloud design principle that's enabled by availability zones. It's rather a computing instance that we use. So it's not relevant to the question here. So I'm going to strike that off. Loose coupling, yeah, this was something I was thinking about a lot, and I was trying to choose between loose coupling and removing single points of failure. But when you think about it long enough, you understand that loose coupling is where you build an application. It's a design principle. It's definitely a design principle where you build like microservices where one service calls another service, and even if the calling service uh, does not get a response from the call service, still the calling service does not like error out. It either tries again, or it goes back with a reasonable message saying I couldn't find it, response was not received. So one of the failures does not cause the whole transaction or the whole application to fail. So that is the concept of loose coupling. In this, I don't availability zone was not very relevant, so it's a different design principle. So I would have to choose B, which is removing single points of failure. Let's look at the next question, which is like related to storage. So we looked at storage, I think, a couple of sessions ago. Storage service, we saw that for a whole session. It was really important. Um, this question here is about storage service, and it is asking which storage service can be accessed by the web browser without using a compute service. So we spoke about this multiple times. There's only one service which is serverless, which can be accessed without um, like setting up a user instance. So we probably know the answer to it, but let's read the options. One is Elastic File System or EFS, Elastic Block Storage or EBS, Simple Storage Service or S3, and Snowcone. Snowcone somewhat doesn't fit in this other options, but let's look at it. EBS and EFS, we spoke about it earlier, and it needs an EC2 instance to access the data. You'll have to mount the file system into the network for one or multiple EC2 instances to use it. And Elastic Block Storage is assigned to a EC2 instance, so it's not even shared between multiple EC2 instances. It is like loaded onto one EC2 instance, and that EC2 instance holds any data into that EC2 EBS, and then you can read from it, write to it, so it can do that. But these two, EFS and EBS, do need a like EC2 instance to access the data. The last one, Snowcone, is an edge computing device. I've shown you a picture, or you can Google for it. It's an edge computing device that you actually get from Amazon AWS. They send it to you by courier. You get the computing device, you transfer all your data, and then you can actually ship it back to AWS. So that is not what they're asking in this question. So it has to be Amazon Simple Storage Service. The next question is, why is AWS more economical than traditional data center applications with varying compute workloads? So they're asking a little bit about cost here. So they're asking, why is it more economical? And they're comparing it with traditional data centers. So they're comparing AWS with your traditional data center or on-prem. And they're giving a specific scenario here saying varying compute workloads. That means the compute could be very heavy during the day, and during the night it might be like pretty much minimal or zero. So you have varying compute workloads, or it could vary across months. So certain months you might have a lot of traffic. Say you're probably a retail website, and during Christmas and New Year you have a lot of people shopping for your products. But when you're in the summer, people are roaming around. They're not really spending time on your website buying stuff, ordering stuff. So there may be different workloads, and that may be varying month by month. So if for this scenario, they're asking why is AWS more economical? And I think the biggest difference between traditional data store and compute workload on the cloud is that on the cloud, when we're not actually using something, we don't have to pay for it. So we can choose to scale up and scale down as we need it. And if we know that the demand is going to be varying, then we can design the system in such a way that we can auto scale it up when we need it, and then auto scale it down when we don't need it. Um, or you could set up other ways where this becomes serverless and this gets taken care of by AWS itself. Given that, let's read the options. A is Amazon EC2 calls are billed on a monthly basis. It's true, yeah, they do bill it on a monthly basis. You don't have to pay for a year for it, but I don't know how that is a huge economical advantage. Just because you pay by for the month, it helps with your payment plan, does not really reduce your cost itself. Maybe, but not very strong candidate. So I'm going to keep it in the side. B, users retain full administrative access to their EC2 instances. For this, like, doesn't have to anything to do with cost. You have full administrative access to your EC2 instance. It's a true statement. This is a confusing statement sometimes if you don't read the question right. You're in a hurry. You might think, oh yeah, this is true. It is a true statement, but it has nothing to do with the cost, and it doesn't compare with the traditional data center. Even the traditional data center, you have full administrative access to your server or your virtual instance. So true, but nothing relevant to the question. So I'm going to strike it off. C, Amazon EC2 instance can be launched on demand when needed. Again, a true statement. You can launch it on demand when needed. It has something to do with the cost, because yeah, you can launch the instance or stop the instance when you don't really use it. So you can that can reduce the cost, but it's not addressing the cost question directly. The last option is users can permanently run enough instances to handle peak workloads. So in this example, um, you can talk about users like running a lot of instances uh, that can actually address the peak workload. So this is something which is not an advantage. You could do this, but it would actually cost you much more to run a peak workload level computing. So the advantage of cloud is actually that you can scale down and scale up. I'm not really satisfied with D. Um, so it has to be either A or C. Given that we struck out B and D, within A and C, A does talk about the cost, does talk about paying it on a monthly basis, but doesn't talk about a reduced cost. While C at least like addresses uh, the reason where we can actually launch more instances when we need, and we can address the varying compute workload. It doesn't really address the billing part of it, the economic part of it, but indirectly it does help with being economical. So I would choose C. I'm not sure. Let me see what the right answer was. Yeah, and it is C. Which AWS service would simplify the migration of database to AWS? This is a very straightforward question. Um, every other option, like when we talk about migration of database, we know that it has to be this service. But let's look at the options. It's AWS Storage Gateway, AWS Database Migration Service, which is what I think the answer should be. Amazon EC2 instance, which is a compute instance, nothing to do with migration of database, nothing to do with database itself. Amazon AppStream 2.0, this is the remote desktop that you get, that you can use if you have your own laptop and you want to get into the corporate network. You could probably get assigned a AppStream device, and then you can use that. The storage gateway is where the data transfer between um, the corporate network and between the AWS network can be like eased up, can be done made faster by using the storage gateway. The storage gateway connects on-premise software appliance with cloud-based storage to provide seamless integration. And Amazon AppStream is a fully managed persistent desktop application for remotely accessing your work. So I think it has to be B. This is a pretty much straightforward question. Around 33% of the questions, or 1/3 of your exam, is going to be very straightforward questions such as these. Um, to my understanding, the remaining 2/3, like some of them would be like very close. You'll have two options, and none of them will hit the answer on the head. So you'll have to choose, which is probably around 20 to 30% of the questions. And for the remaining ones, you might have to think a little bit, but you'll get to the answer. You might have two choices, but one may be clearly better over the other. But the two may be close enough. Which AWS offering enables users to find, buy, and immediately start using the software solutions in their AWS environment? This is another example where it's pretty much you hit it on the head. It's pretty straightforward. If you know what the answer is, you know it. It's very straightforward. And if you don't know, you can use the option of eliminating. So so if you don't know the answer, you don't know like what all the four of these do: AWS Config, AWS OpsWorks, AWS SDK, AWS Marketplace, but you know a few of them, then you can start looking at them and you either eliminate them or say, okay, this might be an answer. Let's start doing that. AWS Config is used to pull in all the config information. So anything to do with assess, like you want to audit your data, you want to evaluate your configurations. So all your configuration can be in one place in AWS Config. You can look at you can assess it, you can audit it, evaluate your configurations for all your AWS resources. If some configurations have changed, you can make sure it's done in the right intention and like make sure you audit it. OpsWorks is where you use a Chef or Puppet for like infrastructure configuration management. So AWS config is where you can just see what configuration every application, every EC2 instance, every other AWS service you use has. OpsWorks is where you can actually manage the configuration in a file where you write down all the configuration and then you can use that to deploy the resources. So you can use either Chef or Puppet for this. Those it's another managed service. SDK, it's a software development kit. Any coder who's using JavaScript would have their own JavaScript AWS SDK, or if you're using like Java, they'll have Java SDK for AWS. So that gives the access to launch or test EC2 instances, everything from their own desktop. They have the whole kit, and they need every tool that they need to get their development work done. AWS Marketplace is the answer to this question. That's the link where you can actually purchase software solutions, packages, install them, and then use it. Which AWS service, networking service, enables a company to create a virtual network within AWS? So here, like we want to talk about virtual network. So they're talking about a VPC, and you want to build a network service within, and it's a virtual service and it's within the AWS. So if you know all that, it has to be a virtual private cloud, which is a walled area within AWS that your company has access to, and you can configure how there are any kind of connections are ingress and outgress happen to the virtual private cloud. What are the other options here? AWS Config, which is like the configuration. It holds all the configuration, and that's where you can actually check it, access it, audit it, make sure there's nothing that has changed for all your services. AWS Route 53 is a domain name service provided by Amazon. So if you want to know what your IP address is, but you want to give your developers a easy to use name, such as my application dev dot amazonaws.com, they would, or if you want to have your company name.com slash service number 1 as your IP address that you provide to your developers or testers, and you want that to be routed onto a AWS service, then you can use the AWS DNS called Amazon Route 53. And this is an important thing that comes up in most questions. So Amazon Route 53 either is a question that's asked a lot about, or it comes as one of the options in most of the questions. AWS Direct Connect. This is where you physically have a connection between your router and AWS's Direct Connect router. So it makes the connection between the on-prem and AWS much faster. So the corporate network, if a corporate network has to transfer data every day to AWS, then you think about AWS Direct Connect as an way of making the network much faster and more importantly secure. Because VPN, even though the data is encrypted, like there could be a malicious player who's smart enough to break the encryption and like, get access to the data that's being transferred between AWS and your cloud. The last option is Amazon Virtual Private Cloud, which addresses this option. So that should be the answer. Which component of AWS global infrastructure does Cloudfront use to ensure low latency delivery? So Cloudfront, Netflix. So Netflix uses uh, something called edge locations, so that your data is provided from a global audience, and they're able to like watch your videos without any caching. I mean, because the videos are cached, so they can watch it without any latency. So to ensure low latency delivery, especially of images and videos, we use something called CloudFront, and these use something called edge locations. So there are edge locations in every locality. So other than AWS regions, there's also a map of edge locations that AWS provides on its website. So you can take a look. Obviously, availability zones. AWS regions are major regions within the AWS network where you could set up certain services. So each region might have a different set of services. Some regions may not have certain services yet. Within regions, you have multiple availability zones, and virtual private cloud is a virtual network within the AWS network. So it has to be the edge location, and that is the answer. Which cloud service will be used to send alerts based on Amazon CloudWatch alarms? So CloudWatch alarms. So CloudWatch is a service where you can log, you can look at data, like from how your services are performing. For example, your DynamoDB's performance, DynamoDB's alarms, if there are any from that. So those can be looked at in the interface of CloudWatch, in the web interface. So if you want to have the alarm send you an alert, say an email, or it has to send that to a S3 bucket whenever there's a like an alarm, and you can set up the alarm to be like if it's 50% capacity, or if there are like three continuous errors, or if there's just one error, you set up an alarm. So you can set up alarms based on multiple uses as well. Which service would you use to actually send the alert? Um, Options here are simple notification service, which pretty closely seems to be what would be the answer. CloudTrail, a trusted advisor, and Route 53. Let's see what these are. CloudTrail, if you remember from our first session, we spoke about this. It helps with understanding from a user perspective, like what that user has done, whether they've logged in somewhere, whether they've logged into EC2 instance, they've deleted the log, they have changed uh, the configuration of the EC2 instance or the configuration of DynamoDB. So all those things can be found using CloudTrail, and this is very useful for governance, compliance. So any legal regulations as to who has done what with um, the infrastructure, that can be easily done by using CloudTrail, and you can also use it for operational risk auditing. AWS Trusted Advisor. Um, it provides you recommendations on best practices. So these are the best practices. So it will tell you from a few categories. You can do this or do that. So that is something that trusted advisor would look at the best practices, look at your configurations, and then come up with some suggestions and recommendations. Route 53 is a domain name service provided by Amazon. We just looked at it. So it has to be the simple notification service. Let's choose that. Move on to the next question. Next, before I go to a question, I'm just going to quickly go through S3. I spent a little bit on S3, but probably a few things that need to get addressed for S3, because S3 is another frequently asked question. And you could definitely expect at least a couple of questions about S3 on your exam. The S3 service takes care of object storage. So if you see the question about object storage, so you know what you're talking about. And if it talks about serverless storage, then again you can easily know that it's talking about S3. how do you actually store your data on the S3? So the S3 service needs something called a bucket. So first you need to create something called a bucket. The bucket has to be globally unique bucket name. So you cannot set up something called Walmart bucket, because definitely it must have been taken up by either Walmart or by other people. Um, but it has to be a globally unique name. So you typically use names and numbers and match it up and then use it. And you always have to choose a region. So you'll have to choose a region where your S3 bucket lives. And within the region, you don't choose availability zones. You just choose the region. And the reason is Amazon, being serverless, AWS takes care of keep creating multiple copies of that in multiple availability zones, so that you always have access to data, even if one of the availability zones goes down. Then there are a bunch of other options you can choose when you create your S3 bucket, including, do you want replication, do you want like versioning. Just remember those things, like replication and versioning. Those are other options you can choose when you create your S3 bucket. But you need to choose your unique bucket name, choose your region, not your availability zone. That's pretty important to understand as well. After you create your bucket, then you upload your file to the S3 bucket. So within the bucket, you go in and upload your file. And remember that the file and the bucket is not like a folder, and within the folder you have your um, files. It's not a file storage system. So it's an object storage. So in the sense that the file that you upload into the S3 bucket is the object, and not only the file, it also stores metadata about the file. It stores size, format, and other information about the file itself. So it has multiple things other than that. And if you had set up versioning in the previous step, when you set up the bucket, when you set up object versioning, then you'll be able to, when you upload a second object with the same name, same file name, and then you upload it, then it will get uploaded as a second version, and the older version gets versioned out as a previous version. So you can if you set up versioning, that happens automatically based on S3. And to retrieve your file, you can give somebody an URL. Somebody can manually go to the URL and look at your file, or programmatically they can call in that URL and they can retrieve that file. And yeah, if you're done with your file or with your bucket, you can delete the file and the S3 bucket, or just the file. So just a reminder, the bucket is a container. It's not a folder. It's a container for your uploaded data, and it always has a unique name. This is a globally unique name that which has a specific URL that you can point to, and then you can that namespace is assigned to you after you choose your bucket name and save it, and that namespace is not provided to anybody else. So you have it uniquely to yourself. An object is an item that is stored within the bucket. To identify the object, like AWS has a key and a version ID. So when the version is not turned on, it could always have the same version ID. If not, it could have multiple version IDs for the same key. What are the features it has? You can set up the IAM permissions for it. It's used a lot for static website hosting, or for your website. You have images, you have videos that are static. That is, it doesn't change dynamically. So those static websites or elements from the website which are static, you can host them on the S3 bucket. You can have any kind of logs based on things that happen on the S3 bucket. You can so that gets logged automatically. You can have events triggered based on somebody uploading or deleting from from a S3 bucket or into a S3 bucket. And that can call a Lambda function, that can call a SQS, that can call a SNS. So you can do something based on that event. You can turn on object versioning, so you can have the objects have multiple versions. Lifecycle management, we spoke about this extensively when we spoke about S3. So lifecycle management is where you can have uh, the um, uh, the storage stored like in Glacier after a year. So after people have not used it for a year, you can actually move that from a storage class, which is like intelligent tiering, to a Glacier, or you can move it from the general storage class uh, to a intelligent tiering after like 3 months, or you can choose that kind of life cycle management where it moves between the storage classes. The next important thing about S3 is replication. So you can set up replication when you set up the S3 bucket itself, not at the object level, but at the bucket level. What replication does is you can automatically copy objects across S3 buckets. So you can set up such that um, certain data within the bucket that have a certain prefix, or it has a certain tag, or you can say the entire bucket would get copied. And then so in this way, even though you don't set it up by object, you set it up at the bucket, you can still be selective about which objects actually get replicated. Say for example, you just want your images that end in JPG to be replicated, then you can set that up. So even though many other objects get into the bucket, only the JPG would get replicated. And when you replicate it, you can choose either the same region replication, that is, it gets into one or more destination buckets, but within the same region, and a cross region replication, which is a little bit more expensive, but it can move from one region to another. And again, it can be one or more destination buckets. And you can also change the ownership of the destination. So you can put it from your corporate account to another company's corporate account, or to another person's personal account. Um, you can also cost optimize with storage classes. So you can change the destination storage class. You don't have the same storage class as what the source was. So let's look at one question about S3 buckets. So when creating Amazon S3 bucket, what level of infrastructure must be specified? So we saw this a couple of slides ago. Do we specify just the region, or do we actually specify the availability zone? Do we specify subnet, which is nothing we specify when we actually create an S3 bucket? And none. Amazon S3 buckets are global, so you don't actually have to specify a region, availability zone, subnet. So this option, Amazon S3 buckets are global, so they do have a global workspace, and they do have a global unique name as well. But when we choose it, we do specify what region it has, because that's the primary region this data gets stored. Just a reminder, we have buckets, and within buckets we have objects, and we have these features that we just spoke about. Couple of things I left out is we have tags that we can put in for each of the objects. So each object can be tagged, and we can, based on different tags, we can trigger different events, or we can put it in different storage classes. So we can, with respect to moving data in, like we can use storage acceleration, transfer acceleration, and we can use storage management. So it's the region, this choice for this. Let's move on to the next one. What does Amazon EC2 auto scaling do? Auto scaling, if you remember, if you have multiple instances of EC2 instances, and if one or more of them are running at a certain capacity level, say 70% of the capacity, right, you don't want it to go above 70%. So you can actually auto scale and add another EC2 instance, which is a replica of the existing EC2 instance, and then your load balancer will know that a new EC2 instance has been created, and then it can load balance with that additional EC2 instance as well. So that is what auto scaling does. Let's read these question answers, and we should probably be able to knock it off easily. Resizes the instance type of EC2 instance based on utilization of each instance. The auto scaling cannot actually resize the instance type. It cannot change the instance type. It cannot change the size of it. It can only create a copy of the EC2 instance. So not resize word throws me off, and I'm going to say this is not it. The next one is launches and terminates Amazon EC2 instance based on metrics from Amazon CloudWatch. Probably um, it does launch and it does terminate EC2 instances, and it does look at the like how much utilization it is from CloudWatch. So this is probably it. Let's keep it aside because I'm um, going to go through the other options to make before I ensure this is the right option. It adjusts the amount of CPU and RAM in these two instances. Again, we cannot like without stopping any instance, we cannot adjust the amount of CPU, RAM, like just because the performance is low or high. This adjustment cannot happen, and easy to auto scaling does not do that. The last one is use historical performance to provision an appropriate number of EC2 instances. This is not done by auto scaling. Looking at historical performance, so the word historical performance is what gives this away. So it rather looks at the current utilization. It doesn't look at like the last Thursday's performance or the last um, week's performance to say this week I'm going to auto scale it up or down. It rather looks at what it is right now. So I'm going to choose 2. I hope that's right. That is. Which of the following pricing plans are the best option for cost optimization when using EC2 instances that are running business critical workloads 24 hours a day for every day of the year? So a few things to note here. They're talking about pricing plans. So there are multiple pricing plans. We looked at them earlier. We'll just look at them again. But they're asking for cost optimization. So the best option for cost optimization, they want the most cost optimized plan. And they want to run a business critical workload. So they want it to run 24 hours a day, every day of the year. So they don't want a stoppage in the workload. So you cannot stop the instance and restart it. And another thing is it's business critical. So with that, the options here are AWS free tier. Free tier is something you get computing power for the first year and some other computing instances as well. You get free tier throughout your entire life cycle. For the first year, you get a EC2 instance as well free. So that is free tier. It's not really a pricing plan, but it's more of like the usage that AWS gives you for free to try. So because that's not, it's definitely like free, so it's pretty much zero cost. You can run business critical workloads and you can run it for 24 hours a day, but you might exhaust your free tier when you exhaust the number of free hours that they provide. I think it's 750 hours of compute power or something that they provide. Spot pricing, I don't know what that is because spot instances are something, and spot pricing may be just a twist on the words to confuse you. Assume I'm reading spot instances there. We cannot use it because they want this to be running 24 hours a day, and spot instances can be stopped whenever AWS needs the spare capacity. And the business critical workloads are typically not run on a spot instance. Dedicated instances are used whenever you have like security concerns, legislative or regulatory needs to have instances that have nothing other than your server running on that. And reserved instances are where you pay upfront for 1 year or 3 years so that you get some savings on the EC2 instance. But you have your EC2 instance reserved, so you have to pay for it whether you use it or not. So these are the 4 options. So if you look at reserved instances, it's the best for long term. It gets up to 70% off, and it's steady state of predictable usage. So we do have predictable usage, so they want to use it every day of the year, and you can commit to easy instances of 1 or 3 at a time. So I would choose the reserved instances, and that's the right answer. That is all I wanted to cover for today. So this is our 8th session. There are 2 more sessions, and with that, we should come to a conclusion of the AWS Certified Cloud Practitioner. At the end of the session, I'll also provide a link where we have a number of questions and like a WhatsApp and a Telegram group where we can connect with other folks who are taking the AWS Certified Cloud Practitioner exam, and you can ask questions, help each other out. Thank you so much for watching today. Don't forget to like this video and subscribe to this channel for more AWS related materials. Thank you.